This video is on geometric sequences. We're going to do some practice problems to find the common ratio, our a sub 1, our recursive and explicit, both explicit equations, and then we're going to be able to use that to determine our term that we want to find. So question 1, we have the sequence of 12, 24, 48, 96, 192. We need to see how this increases. So we can do the second term divided by the first, and we can do the next term divided by the previous to determine our ratio. So 24 divided by 12 is 2, 48 divided by 24 is 2, 96 divided by 48 is 2, and 192 divided by 96 is also 2. So our common ratio is 2. R is equal to 2, because we would multiply by 2 to get each of our terms. Now let's go ahead and go backwards to find our a sub 0, our 0th term. If I were to go backwards, we would need 6 as our 0th term. So our y-intercept would be 0, 6. Our first term is in fact 12 because that was what we were given, but we need to go backwards to find our 0th term as well. So the recursive form is written as a sub n, so our next equals our now, so a sub n minus 1, times, how do we get to the next term? If I want to get to the next term, I would just multiply by 2. But we need to know what our starting value is. So a sub 1 is still equal to the 12. This is our recursive form. Next equals now. So we would multiply by 2. The explicit, there are two different explicit forms. There is the a sub n form and then the exponential equation form. So our first way of writing it is using the a sub n. So a sub n is equal to our a sub 1, which is 12, times our common ratio, which is 2, raised to the n minus 1. And this is our explicit form for a sub n's. But you can also have your exponential equation, which is y equals. Now, our y equals, we need our y-intercept, which is why we needed our a sub 0. So we'd actually have 6 as our a value here, times our common ratio is still 2, raised to the x. So our second explicit is using y and x. Now, if we want to find the 10th term, we could use either one of our explicit forms. We can use either one of our explicit forms. I'm going to show both. So if we want a sub 10, I'm going to use the first explicit. This would be equal to 12 times 2 raised to the 10 minus 1. And for the other explicit, we would have y equals 6 times 2 raised to the 10. Both of these will give us a sub 10 equals to 6,144. Both will give us that. Because this will become 10 minus 1 is 9, so this will be 2 raised to the 9th, and then you multiply by 12. So for the second one, we need to find, again, our common ratio. We would take our second number and divide it by the first. So 4 divided by 12 is 1 over 3. 4 divided by 12, we have 4 thirds divided by 4. 4 ninths divided by 4 thirds. 4 27ths divided by 4 ninths. All of these give us a 1 over 3. That is our common ratio. 1/3 is our common ratio. Using the next term divided by the previous will give us our common ratio. So our R is equal to a positive 1/3. Because if we just multiply by 1/3, we'll get the next number. So let's go ahead and go backwards to get our a sub 0. So if we multiply by 1/3, we'd have to divide by 1/3. 12 divided by 1/3 is going to give us a sub 0 of 36. That a sub 0 will help us with our second explicit form. So the recursive form is our next, which is a sub n, equals our now, which is our a sub n minus 1, times, I would multiply by 1/3. But we need to know our starting value, so a sub 1 is equal to 12. The explicit forms, we have the first one using the a sub n. So a sub n is equal to our a sub 1, which is 12, times 1/3, raised to the n minus 1. Our second one is the just basic exponential equation, which is y equals our a sub 0, so our y-intercept, which would be that 36, times our 1/3 is our common ratio, raised to the x, because we have to use y and x now. So both of these explicit will help us find the 9th term. So I'm going to show both to find the 9th term. If I want a sub 9, we're going to use 12 times 1/3 raised to the 9 minus 1. Or we can use y equals 36 times 1/3 raised to the 9th for the 9th term. Both of these will give us a fraction. We have to put math enter to get a fraction. A sub 9 is equal to 4 over 2,187. Don't give a decimal. We want the fraction. On question 3, again, we want to find the common ratio. So we're going to take the second term and divide it by the first. The 100 divided by 500 is 1/5. 20 divided by 100 is 1/5. 4 divided by 20 is 1/5. 4/5 divided by 4 is 1/5. So r is equal to 1/5. Because if we multiply by 1/5, we'll get the next number. So let's go ahead and find our a sub 0 by going backwards. So we're going to divide by the 1/5. So 500 divided by 1/5 gives us 2,500. So that gives us our y-intercept of 0, 2,500. This helps us for our second explicit. That's the only thing it helps us for. So recursive is next a sub n equals our now a sub n minus 1 times our 1/5. Did not mean to put 1/4 here. That's supposed to be 1/5. So a sub n minus 1 times 1/5, starting at, so that's our a sub 1, is 500. Our first explicit is using the a sub n equals our starting value of 500 times our 1/5 raised to the n minus 1. So again, we still need the a sub n, we still need the a sub 1, and we still need the n minus 1 in both recursive and explicit. But for our second explicit, we use the exponential. So y equals our y-intercept of 2,500 times our common ratio, or our factor, of 1/5 raised to the exponent of x. So our 13th term, a sub 13, will equal to 500 times 1/5 raised to the 13 minus 1, or we'll have y equals 2,500 times 1/5 raised to the 13th. Both of these will give you a very small decimal of a sub 13 equals 0.00000, so 5 zeros, 2048. This one does give you a very small decimal. And this next one, so again, we're going to take our 5/6 and divide it by 5/36, which actually gives you 6. 5 divided by 5/6 gives you 6. 30 divided by 5 gives you 6. 180 divided by 30 gives you 6. So our common ratio, our R value, is equal to 6. So if we multiply by 6, we get to the next value. So let's go ahead and go backwards to get our a sub 0. So we're going to, instead of multiply by 6, we're going to divide by 6. So 5/36 divided by 6 will give you 5 over 216. This is our a sub 0. Again, this helps us in our second explicit form only. Recursive. Next, which is a sub n, equals our now, which is a sub n minus 1, times our common ratio of 6, starting at, so a sub 1 equals 5/36. Explicit. The first explicit is our a sub n equals our first term of 5/36 times 6 raised to the n minus 1. Our second explicit is our exponential, y equals our y-intercept of 5 over 216 times our common ratio of 6 raised to x. So to find the seventh term, we'll do a sub 7 equals 5 over 36 times 6 raised to the 7 minus 1, or y equals 5 over 216 times 6 raised to the 7th. Both of these will give you a sub 7, the seventh term, being 6,480.